All right, good morning, class. I hope you're ready for another day of learning. Today, we are going to go over volume. But first, let's do some review from yesterday. We worked on area. Volume has some to do with area. It's a little bit different, but we're going to review this, that way we can move on to volume. So let's first look at the square. All right, we have 4 different squares here. And remember, we were decomposing and composing in order to find the area. So we have 4 different blocks here. And to find the surface area, the area of this square, we need to put the sides together. So we have a block here that's 2 by 2. This one's 2 by 2, 2 by 2. So in order to find the area of a square, what do we do? Yes, I have right there, S squared. So that's S means side, right? So this side is actually going to equal how many? How much, Kelly? If this right here is 2, we have to add this also because we're putting it together. We're composing these 4 together. Right? This side would be 4. And if this is 2, this also is. This is also 2. Which equals 4. So then we have to multiply 4 by 4 times 4, and this area is going to be 16. Good. And then we have this shape right here. All right, this one was a little bit trickier. This is when we're taking a figure and we're splitting it in order to find the area, because we can't do the area of a square for this, right? It's not a square. We can't do side times side. They don't have equal sides, right? Okay, and we can't do a rectangle because this is missing this much of the rectangle, right? We don't know what this means. We don't know how much this is because we're missing this, right? So what we do is we decompose it into a triangle, and we use a formula half base times height. This is a lowercase b, okay? Remember that, half base times height. So this is going to look like half times, what's our base, 8 or 10? It's actually going to be 8, because if we flip this around, it doesn't really matter which one you do first, because when we're multiplying, can we move this in any way? Can we do base times height, then times half? Right. So we're going to put in the 8 here, then the 10. All right, let's do 8 times 10 first. 80. Multiply that by half. We have 40. So the area of this triangle is 40. And I didn't put in any numbers in for this triangle because we're just reviewing. Let's go up to this one. Here we're missing a section, right? So how are we going to figure out what this section is? We're going to compose it, right? And we're going to find the area of this rectangle and this rectangle. So we're going to first find the area of this rectangle, right? Which is length times the width. So our length is what? 10. So we're going to have 10 times our width, 12, which is 120. Why is this not our answer? Why can't we not just stay with 120? Why can't we just do the length times width and then call it good? Right, because we're missing this section. So this section is not a part of this surface area, right? If this was laying on a table, this part would be all covering the table, but this part would still be the table, right? So how do we get rid of this section from 120? Right, so we'll do 8 times 4 is 2. And we're going to subtract this, right? So our total area for this figure is 88. Good. All right, so now we're going to move on to volume. All right. Oh, you can see my board a little bit better. Maybe. Okay. So, this is the only time let you guys do this, but pull out your phones. Alright? Here is what your phone looks like, right? It's like a rectangle. That was a very bad rectangle. If the top of your phone is 2 inches and the side is 6, what's the area of your cell phone? Everyone look at your cell phone, pull it out, hold it a little bit. 2 times 6, 12. The area of your phone is, the surface area of your phone is 12, right? Now, if you lay it on the table, is it flat on the table or is it a little bit thick? Alright, now I want you to measure the thickness of your phone, or as I like to say, the volume of your phone. How much space does your phone take up? It's all squished together, it's taking up volume. It's the amount of space an object takes up. So, go ahead, look at your phone, tell me what the measurement is. You don't know how to calculate volume? Well, it's a good thing you're learning it today. So, when we're looking at your cell phone, okay, how we're actually going to draw your cell phone if we're trying to get the volume, which is pretty much, we'll find the area is 12, okay? That's like a flat sheet of paper, right? The area of this piece of paper, pretend this is 12. You see how it's flat? So it's not taking up any volume. Now, if we have a stack of papers, this is taking up more room than this, right? This has more volume because it has a bunch of papers stacked together. So you can take a flat object, stack a bunch of them together, and you get this thickness, which is volume. Okay? So it's pretty much area just stacked on top of each other. So, how do we find the volume of your cell phone? Okay, I'll have you guys put your cell phones away now because we'll just move on to a rectangle here. You can find the volume of your cell phone some other time. Okay, so let's look at this right here. The formula for volume for a rectangle is V for volume equals your length times your width times your height, okay? I was going to bring in some cubes or some blocks today and I couldn't get any before the lesson, so I drew some blocks here for you to get a little bit more of a representation of it. All right, this is one block. Each block is a square, okay? So it's 1 by 1 by 1, it's all ones, right? So the length is 1, the width is 1, and the height of this one is 1. Now when we stack them together, we're creating a different volume, okay? So this rectangle is composed of blocks like this, okay? So to find the volume, we'll do the length times the width times the height. What is 3 times 1? 3, good. What is 3 times 4? 12, good. So the volume of this is 12. So that is what's inside. This is the surface area. We talked about over here was surface area, so it's just how much you see. So if you look at a window like this, you're not going to see how thick the window is, right? You're just going to see how much space it takes up, how much surface area it takes up. This is looking at the volume, the thickness of it, the amount of space filled or taken up, right? So now let's look at this block, okay? We have how many blocks here? 1, 2, 3, 4. And each block has a side length of how much? 1. So if we do 1 plus 1 plus 1 plus 1, how long is this side? 4. Alright, we have 3 blocks on the bottom. We have 1, 1, 1, right? Because that's how big the side length is here. So that'll be 3. And how big is the width? 1. Yes. Which is kind of confusing because we have all these blocks, right? But the width is still the same throughout it all. So if we're going to find the volume of this, what are we going to multiply? Which is the length? If we're following this, length times width times height. 3, right? 3 would be the length. What is the width? 1. And what is the height? 4. And the answer, what's 3 times 1? Yes, it's 12. That's the same numbers as this one, right? Good catch. Good. So you see how this is just a different version than this, right? We're still compacting cubes in here. We can put 3 by 4 cubes, right? Let's do one more for a rectangle, all right? For this volume right here. This one's a little bit different. This one's taller. So which one here is our length? Which number? Not the 10. That is actually our height. I switched the sides, but that is actually our height. Our length is going to be 8. So we're going to have 8 times our width, which is 4, times our height, which is 10. This one's a little bit bigger. So I'm going to tell you what 8 times 4 is. 32 times 10. Remember when we're multiplying by 10, we just moved the decimal right here over 1. So the volume of this is 320. Alright? So I have a worksheet for you guys to do to find volumes of rectangles. So go ahead and pick those up. They're on my desk. And then when you're done those, or I'll give you a couple minutes to finish those, and then we'll move on to finding the volume of a cylinder. Alright? Alright, so was that pretty easy finding the volume? Does anybody have any questions about what volume is, or why this works or anything like that? No? Alright, great. So now we're going to look at a cylinder. So what kind of things do we see as cylinders? Like if you were to find a shape like this that had a circle top, it was like a circle and went straight down. Name just some cylinders. It's a rectangular cylinder. How about like a can of soup? Can of soups, right? You know how they're a circle but they go all the way up, right? Let's see what else. I like to think of water bottles sometimes. They're not perfectly circular, some of them, but some of them are. They go straight. Or cups. Now cups wouldn't really have a big volume because you can fill them, right? And same with the can, you fill them with stuff. So when we're finding the volume, we find out how much space is taken up inside it all, right? All right, so I have an example here quick. Because I know this might be kind of tricky trying to figure out how a cylinder relates to a rectangle, right? This looks harder than this because, length times width times height, that would be easy. How in the world do you find the volume of a cylinder? Well, if you look at this water bottle, I know, like I said, it's not totally circular and all equal and everything, but it's wrapped up, right, in a piece of paper. A lot of things that we get have like labels on them, like a lot of our cans have labels. If you were to unfold the labels around the cylinder, you'd get a rectangle. So that's why this is called a rectangular cylinder, what we're working on today, because it's a rectangle just folded. Just put in a circle. See the top, bottom, alright? So when we're working on cylinders, to find the volume of a cylinder, this is the formula for it. Now remember how I told you guys to pay attention when we did the surface area and how the B was lowercase? Is this one lowercase or is this uppercase? It's uppercase, right? It's a capital B. What this means, all right, we're going to take the base of this. This is volume equals base times height. But this base is the circle bases, right? We're looking for the area of the base, okay? Because this right here and the bottom are going to be the same. We're looking for the area of the base. So when you see a capital B, volume equals capital B times H, we're looking for the area of the base. So how do we find the area of a circle? Does anyone remember? All right, I have the formula right here. A equals pi r squared. So when we're looking at this one right here, how are we going to find the area of this circle? What's the radius? 8 is the radius. So if we have this formula, A equals pi r squared, where's the 8 going to go? Is it going to go here? Is it going to go in for the pi? Is it going to go in for the r? Right. 8 squared. All right, what is 8 squared? Good, 64. 64 pi. All right, so this is the area of our circle. Now, we're not done yet. We're not looking for the area of this. We're looking for the volume of the whole cylinder, right? I made that way too big, didn't I? Let's make this 10, all right? This is our height. So we have our base, our area of the circle, right? Which is this capital B, and now we need our height, which is 10. So we're going to take V equals 64 pi times 10. So our volume of this cylinder, 640 pi. That's pretty big, isn't it? Have you guys seen like the big what do they call? They like cold food? Yeah, you know what I'm talking about. The farmers. Yeah, those. That's like this. That's like the cylinder, right? And gets filled with feed, and the volume that feed takes up. Maybe it goes to here. Maybe it goes all the way up. But yeah. Now let's look at this one right here. This one's a little bit different than this. This is a little bit trickier. It looks kind of funky, doesn't it? Yeah. I'm not really sure what would be like this. Maybe it's a small can of soup or something. I don't know. But how are we going to find this one? Same way we found this one, right? So first we need to find the area of the circle, right? Which is pi times 5 squared. And after we do that, we're going to multiply by the height, 2. So we'll have, if I switch this up a bit, 25 times pi times 2. So our answer for this one, volume equals 50 pi. All right. I have a worksheet for this one too. So we'll start working on that one. If you did not finish the rectangular one, that is okay. We will come back to it tomorrow, so make sure you bring it. Same with this one, we'll work on this for a little bit and then we'll review. Yeah, so go ahead and grab those sheets and we'll get started. All right, now that we've worked on those for a while, we have a couple minutes left, so let's just go over some review really quick here. Did you guys think that worksheet was easy or hard or okay? Oh, you finished it? Good job. Good job. Okay. Let's just draw a quick rectangle here. We'll make this 10, 12, and 4. We'll make it hard. All right. Someone tell me what the formula to find the volume of a rectangular prism is. V equals length times width times height. Good. What is our length in this? 12. Good. What is our width? Oh, not 10. 4. Good. And our height? 10. All right. What is 12 times 4? Good. 48. What's 48 times 10? Remember, just move the decimal over 1. 480. So what is the volume of this prism? 480. Good job. Are there any questions about finding the volume of a rectangular prism? Good. What are some examples that you can find the volume of that are rectangular prisms in real life? Yep, we talked about the cell phones, your laptops. These are all small volumes, but yep. How about a cake? Anybody like birthday cake? You can find the volume of a birthday cake. We should do that. I should bring in cake sometime and we'll find the volume of that. All right, let's do a cylinder quick. We'll make this 4. Make this 10. How do we find this? What's the formula for it? V equals, am I putting a lowercase or an uppercase B? Good, uppercase H, good. All right, so now we'll do V equals, how do we find this? Yep, what's 4 squared? 16 pi, yep, times 10. We'll do our distributive property. V equals 160 pi. And that's our volume for the cylinder. Good. Good job today. Bring in your worksheets tomorrow. I have it on the board here. We will be drawing polygons in a coordinate plane, so bring your brains. It's going to be tricky. And also bring your worksheets. We'll finish those up tomorrow at the beginning of class. All right.